Good morning, all. Hope you're well. Welcome to our webinar on drone operations. I'll start by saying, I'm Joe Hyde, and as Emily said, I'm a senior drone technician at Ether and also a UAV pilot. Talk a little bit about Ether because I'm sure a lot of you sort of know who we are already, but I'll just explain to you we're Ether. We're a drone sales and solutions company. We don't just do the sort of normal box pushing and selling. We also do consultancy and software and also the aftercare after sales. We're all drone pilots here as well, and we know how sort of operations go, and we can help out and help your company sort of get forward with your drone operations yourself. Today we'll be covering the key stages to conducting a successful operation. I'll be going through sort of my way of how I conduct a drone operation, and it's not going to be sort of a be all and end all of drone operations, but this is how I like to do it and how I think is a good way to get started if you wanted to get into drone operations. As Emily said, if you have any questions during the presentation, please type them in the chat box. I will be pausing, and Varun will be pausing at the end of our sort of sections to ask any questions too. So I'll pass you over to Varun now at Hammer Missions, and he'll give you a little intro into their company.
Hello, everyone. Thanks for joining in today. So thanks, Joe. So I'm Varun Sarwal, and I'm the founder and CEO at Hammer Missions. And essentially at Hammer Missions, we're a software company, and we provide software for drone mission planning and 3D data analysis. Since our inception, we've seen 10,000 drone flights on our platform in 140 different countries, and it's great to be a part of this sort of amazing growing industry. We're based in London, and our vision is to power the future of aerial work by being your software partner in drone operations. Looking forward to talking more about mission planning, data analysis, drone operations today. Yeah, so that's us in a nutshell. Thanks, Joe.
Thank you very much, Varun. Okay, well, I'll get started first on the overview of operational planning. So this will be what you do before a job or a mission to prepare you fully for risk assessments and going through the objectives of the flight and good tools that we can use to sort of get your mission going. I'll first walk through the objectives that we go through, so considerations, then go through tools, and then some checks on site and off site. Okay, so before we conduct a drone operation, there's some considerations to take into account. So first of all, what are you going to what data is needed? What are you going to be, why are you flying it? Whether you're conducting a simple roof survey for visual analysis or conducting a detailed digital twin using photogrammetry, even using thermal analysis or a aerial LiDAR scan. This choice will impact all subsequent aspects of your operation. Once you've decided on data capture, you'll have to choose what aircraft. I know many people will be limited to just the aircrafts in their fleet, but maybe that will sort of change the way you think about your fleet. If you need to do some other aspects of flying, then maybe that will sort of impact the considerations you take. And then once you've got sort of your aircraft and payload and what data is needed, then you can start thinking about what flight plan is needed. So will you be just doing a manual flight of a roof? Will you just be doing a facade scan at all? Or will you want to be using more advanced or mission planning software, say for LiDAR operations or sort of advanced data capture? Then you'd be wanting to use more automated software to get that capture really, really well. All right. So we're going to start off with the sort of pre-planning and operational planning aspects and good apps to use. The apps that I use myself every day when I'm doing a mission. Okay, so we'll take you through Drone Assist, NoTime Info, and Dronedesk for the operational planning. Then I'll also show you a couple of weather planning apps. So to start with Drone Assist, so this is a app by Altitude Angel. It was formerly sort of branded with the NATS, but they've gone into their own tool. It'll show the restriction zones of aerodromes, prisons, and military sites. It also shows warning zones such as train lines, schools, parks, and displays ground hazards such as power lines, pylons, and radio towers. The app will then generate an area report summarizing all of the hazards for the area that's currently on screen. As you can see on the screen there, that's just sort of a local place to us, showing the Chichester Goodwood Aerodrome, and also all the ground hazards, seeing the pylons and the school just in the top. Dronedesk can also be used as a flight reporting tool. So using their unified traffic management system, you can draw a circle or a polygon or a corridor to define the area that you'll be flying in. Then you can say the start time, duration, max height of the operation, and give it a description seen on the right-hand side. Then once you press submit, your planned flight will be available for all users on the app to see, which will also minimize sort of airspace incursions, and any other operators in the area will know that you're working there. And another great feature of Drone Assist is the ability to enable airspace alerts. So when active, it'll provide notifications of other air traffic, so long as they're using a ADS-B transponder. And yeah, while you're conducting your operation, it will give you constant notifications of there's traffic to your northwest 5 miles away or something. So yeah, that's Drone Assist in a nutshell. It's a really good app to use for flight reporting and stuff like that. Next, go on to NOTAM info. So that gives a much more in-depth look into the NOTAM, so notices to airmen that are sort of in your operation zone. As you can see on screen here, we've just showing you like a high-level overview of the whole of the UK, and that was sort of taken last week, of all the sort of NOTAMs in the area. You can select the day of the week that you want to do for the week ahead, or you can just select the whole week as we have here. As you can see, we have all the options selected in the top right-hand corner, but for sort of drone usage, we'd be really looking for the navigation warnings. So there will be the restriction zones and the NOTAMs, and also other reported drone flights in the area will show up on NOTAM info too. And you probably want it to go to your desired altitude. See on this screen, we've got flight level 55, so 5,500 feet, but you probably wouldn't be wanting to do that for drone operations. You'd probably go a bit lower. The next app that is a great help for us and really sort of minimizes the admin needed during drone operations is Dronedesk. So Dronedesk is a great tool that encompasses all the aspects of the previously mentioned apps. So the unified traffic management of Dronedesk goes into this, and sort of NOTAMs and flight logs, but it also combines it with all other aspects like your own assets. So you can upload all the aircraft in your fleet, battery logging and stuff like that. You can sort of input your own risk assessments and site plans really easily on this, and also checklists, and then that will all combine it all together and create one simple, easy job pack, which will be a sort of easy to read all-in-one document, which tells you all about the job that you're going to undertake. I'm just going to change sharing on my side to a job pack that we've recently done. So this is just a sort of I've grabbed one from the archives. Yeah, so this is just a job that we've done in the past. And this is the document that it will generate. It will do all the dates, client details, sort of a job description that you input, but then it will generate all of this. What three words, addresses, postcodes, pilots. And then this is sort of the big bit, is the sort of concept or operations. You can have sort of a template on this. Then when you just press upload, it will upload it all into this. You can have all your operational notes and emergency procedures. And then this is where you create your site surveys. So you'll take in consideration all the nearest traffic control centers, all different checklists that you're going to perform before operations. And then site plans, it will upload. And then it'll also take a sort of high level overview of the restriction zones, and also give you all the local aerodromes that you need to know. You don't need to know all of these, but they're there if you need them. It will tell you the directions they're in and also give you a contact telephone number. That will do that all automatically. You don't have to search your nearest aerodrome to your operation yourself. It also give you nearest A&E hospital automatically. So anything goes wrong, then this will is a great help to have that there. And then also give you a sort of weather forecast of the day that you're planning on flying. And then any new times in the area, but there wasn't any on the day. Also, it uploads your predefined risk assessment, and you can go in and change any of this at any point. If you need to change any of the hazards, any of the risks, then this will create this very detailed risk assessment and also come up with a initial risk and a final risk, just like you do on every flight. So that's basically Dronedesk and how that can help. It basically minimizes your admin time. Instead of going through and creating a job pack manually or a risk assessment manually, this will do this all automatically, and it's really, really helpful for us. Okay, let me just get back to the presentation. So onto weather planning. I'm sure this is a bane for all drone operations, especially in the UK and recently in the past week. Hasn't been too pretty outside, but what I use, particularly sort of before the day, is really accurate is UAV forecast. So you can set all your parameters that you want to know about in here and set different considerations and limits, and then they'll flash up in red if it's over your particular limit for your aircraft. You can also check different heights, wind levels at different heights, and visibilities. It's just really, really convenient and puts it out in a really easy to view manner on a sort of phone app and also on the desktop app as well. Next on to Windy, which I like the most. I feel this is one of the most accurate sort of forecasting apps for wind levels. As you can see, this is over the past week that I've taken a screenshot, so looking really horrible out there. But it'll also show you sort of weather radars and rain precipitation radars, and I like to use it just for checking what the wind, and I found that it's really accurate for wind predictions. Okay, so once you've done all your sort of pre-flight weather checking and stuff, you want to go for your area checking. I believe it's really important to always study the area of operation before you get onto site, just so there's no little surprises waiting for you when you get there. You might not know the elevation of a building, for say. You might sort of have a target building and then have some other larger buildings or smaller buildings next to you, which you didn't know how tall they were. So it's always good to use different apps for that. Say the differences between Google Earth and Google Maps. I usually use Google Maps just to quickly find a different location or quickly just find an area. But then I hop into Google Earth or Google Earth Pro and use its 3D tools. They're really useful for finding out a lot more about your area of interest. Also to see the elevation of the ground really helps. We had a sort of operation where we didn't really know. On Google Maps, it was just showing you the satellite view and just showing you sort of a plain field. And then when I hopped into Google Earth Pro, I could use a 3D app, and it was actually a really high elevation change in the area that we were mapping. Another thing to use is say OS maps, or there's a free sort of footpath map online that you can find, where that can show you sort of public footpaths and any incursions that you may occur. Just so you know, say if you're in a field somewhere doing a large area survey, then you know where a public incursion could come from. possibly, and also Earth map shows very detailed elevation data. Okay, so once we're on site, I always like to do a site recce. So that'll just be an area check, just to sort of confirm your risk assessment, check all different aspects. Say if you're doing a building survey, oh, there wasn't a tree that I noticed before, but now I can see that that's fully grown and it's impinging on the building that I'm going to survey. That would sort of, you'd want to note that down in your risk assessment. Populate any new hazards or risks that you find. You'd want to check where's best for takeoff and landing zones. So find a good suitable sort of stable ground site for your takeoff and landing, preferably away from public areas, and maybe where it can't be moved. But then again, we have had times where we've gone around and we're like, we need to have a dynamic sort of takeoff and landing site. So takeoff and landing sites don't need to be in the same place each time. Yes, the return to home will return straight to that point if you've got it set like that. But say if you're doing a building and you're going around a building, then you'd probably have a takeoff site at one side, and then as you're doing this scan around, then you might have the landing site at another end. So yeah, just take that into account in your site recce. And then talking about emergency landing sites, a lot of people are sort of told and they think that you should have a defined emergency landing site. But myself, I believe that during the flight, you should be dynamically assessing where you could potentially land if an emergency occurs. So anywhere is good out of public harm or out of anyone's harm. Say like a tree, for instance, is probably preferable if I'm in a city area for an emergency landing. If there is, say, a propeller, I'd want to try a propeller outage. If you can try and steer your drone away, then yeah, you can't really say, oh, if there's an emergency, I'm going to land there, because your emergency could happen when you're several hundred meters away. So you need to be dynamically risk assessing where your emergency landing site could be. So another important thing, I think maybe one of the most important, is facilities checking. So when you're on site, you don't want to be caught out, needing facilities, needing toilets and so on, and food spots. When you're sort of halfway through an operation, you want to kind of know where the nearest place is to go. And if you're going to be on site all day, it's really important to know that they're available. Then your permissions check. So that would be final sort of, have you got all the relevant permissions for the land that you're operating on, for the building you're scanning? Has sort of calls been made to the landowner, just informing that you're going to start your operation. Inform police if required. So ourselves, we do like to call 101. That's the UK non-emergency. Anyone out to the UK, I'm not too sure whether you have a non-emergency police number, but we can call that and we can talk to an operator and tell them that we're taking up a drone and we're fully sort of qualified, and they always take down a postcode. And it's basically a courtesy, just in case we get any people calling the police saying that, oh, we've spotted a drone, do something about it. At least they know that we're on site and we're qualified to be flying there, and we've got all our permissions in check. They're always thankful when I call them, and I always give them a call afterwards to just let them know what we've finished, and just inform them that we're not going to be on site anymore. So if they do get calls from then on, then yeah, it might be a rogue pilot or someone that's not meant to be there or something. So you prefer, once you've done all that, you want to do your final risk check. So prepare your final assessments, amount of uninvolved persons or traffic. So when you get into sort of a congested area, just take a quick note of, oh, the traffic's sort of light to moderate or medium to high, then that will impinge on your risk assessment as well. Take a final wind and weather check, whether you're using an actual tool for that or just checking it with your own sort of experience. and checking the weather conditions as well. Is there any rain coming that's going to impact the rest of your flight? Also check any birds in the air that can always sort of impinge on your drone operations. And yeah, make your final go or no go call, and finally take off and conduct your mission. So that's the end of my sort of operations explanation and how I go about my operations. If there's any questions on that, then let me know. And I'll just pass over to Varun on hammer missions.
Yeah, thanks, Joe. So as Joe mentioned, we're going to talk a little bit more about mission planning now, and how you can potentially plan your drone missions. But before we go into talking about how to plan drone missions, I think it's always great to sort of start with why and sort of try and understand why we do what we do in drone operations. So it's one of those foundational concepts to always sort of go back to understand the why behind mission planning and automation. And so I think from our perspective, the main reason why you want to do mission planning is because you want to collect high quality data. So a lot of times we see drone operators looking at mission planning from an automation point of view, and I think it's in our human nature to get fascinated with automation. But really, the main reason you want to use mission planning is because you want to collect high quality data. And when you say you want to collect high quality data, one of the questions that automatically stems from that is, how do you even define high quality data? So from our perspective, we define it in three ways. So first of all, data that is collected using mission planning needs to cover the entire asset or site. So if you're doing a roof inspection, facade inspection, or wind turbine inspection, you don't want to have blind spots in your data. So you want to make sure you've covered everything. You don't want to get back to the office and realize a part of the roof was missing or part of the facade was missing. So the first and foremost is coverage, complete coverage. The second thing in how we define high quality data is whether or not the data was collected with the right overlaps, the right altitudes, the right flight settings. And all of these flight settings are very much dependent on what data you're trying to collect. So what GSD or ground sampling distance you need to have in your images. So being able to set that is very important, and mission planning allows you to pre-plan your flight so that your drone follows those settings during the flight. And third, last but not the least, you want to make sure that your images are clear and focused, and they are essentially devoid of any motion blur, because even if you've got the entire asset or site covered and you've got the right altitudes and GSD, you don't want to come back to the office and realize actually some of the images were not clear, they were not focused, and now you can't actually use them to process the data. So that's how we define high quality data, at least the first top three things in our mind when it comes to high quality data. But moving on from the quality of data, we think that mission planning also plays another role, which is it allows you to understand the estimates for your flight and the efficiency that you can expect from a flight. So the first and foremost is essentially being able to estimate the amount of images or batteries you might need on site. So depending on your mission, you might need more than one battery, and mission planning allows you to understand beforehand how many batteries you need to carry to the site. Also, the same way it allows you to understand how much space you might need on your SD card, or would you need multiple SD cards if it's a large mission. The second estimate that allows you to correctly identify is what flight speed is the optimal flight speed for your drone. So in the drone world, flying as fast as possible is not always great, because if you're flying really fast, maybe your camera cannot keep up with the drone and you miss pictures during the flight. So mission planning, again, is a way for you to understand what is the right speed. You also don't want to fly too slow, because you don't want to be on the site all day. You want to have some efficiency in your operations. So finding that sweet spot is really important, and mission planning allows you to really identify that. And the third thing over here is essentially to minimize human errors on site. So one of the things that mission planning allows you to do is pre-program your flight. So sort of, I think referring to Joe's section, just like on Google Maps, you can build an understanding for what the site looks like and what the hazards might be. you can use mission planning to understand what the drone needs to do in flight and pre-program that so that you don't, if the drone deviates or does something different, you know, you have a good idea what to do in that moment. And the last but not the least reason, overarching reason why mission planning is important, and I think this is very much where the future is and where things are going, is got to do with flight repeatability. So one of the things we're seeing more and more of is that people are conducting repeat inspections, repeat surveys with the same operators, and you can expect to do a job and then redo the same site or the same asset every 6 months or every 12 months. And so mission planning allows you to save the mission plan so that you can repeat the flight quite easily. So essentially, it's enabling frequent inspections. But more than that, it allows you to repeat those inspections with many different types of sensors. So if you're doing a roof survey, you could on the same day do both a visual and a thermal survey so that you can get a multi-sensor view of the roof. So you can understand the roof from a visual contextual point of view, but you can also understand its thermal properties using a thermal sensor. And being able to do that with 2 different types of sensors is, again, something you can enable using mission planning. And last but not the least is sort of the 4D change analysis side of things. So where we think the future is that we're seeing operations being conducted on the same site multiple times. 3D data is being captured off the same site multiple times. Which essentially is allowing site inspectors or asset inspectors to build a 4D understanding of the site or the asset and understand what's changing in that asset over time. So this essentially, from our perspective, underpins the future of predictive maintenance, where you can essentially think about building a condition change understanding of your asset or site over time. So that's sort of how you would go about sort of collecting data and using mission planning to collect data for that purpose. So now that we understand why you would collect data using mission planning, I'd like to sort of show you how you could do the mission planning in Hammer Missions. So I'm just going to share my screen. All right. Hopefully everyone can see my screen. All right. So brilliant. So what I've got here is basically Hammer Hub. So essentially, it's a web-based product where you can plan your missions, and you can essentially, what you see on the map is basically your current location. So this is the office building where I'm doing the webinar from. And let's say I wanted to inspect this particular roof. The way you would plan this mission in Hammer is that you would essentially go into the tasks menu. And in Hammer, the approach we've taken to mission planning is that we've understood that you might be doing one mission one day and another mission on a different day. And what you don't want to do is you don't want to switch between different software for different tasks. You want to build consistency in your workflows. And so we integrate different tasks or different types of missions into one software platform. So with Hammer Hub, you can choose a roof inspection if that's what you're aiming to capture. And Hammer will tell you to draw a polygon over the inspection area. And in this particular example, we are planning to capture this roof. So essentially, I will draw a polygon over the roof. And you could also, instead of drawing a polygon, you can import a KML, because sometimes we see that operators receive a KML file from their clients, so you can essentially import the KML file directly. Once I've added the polygon, Hammer will generate a default flight plan for the roof, which you can go into the settings and configure. So this is very much about building the flight efficiency and optimal metrics that I mentioned earlier. So you can see with this default flight plan, you would essentially fly for 5 minutes, 1 battery, 40 pitches, but you might want to fly at a lower altitude. You might want to have less overlap in your images. So you can adjust all of those properties in the flight settings. And once you've done that, you can then simulate your mission. So by hitting the play button, you can essentially see what the drone will do in flight before you get to the site. So again, this allows you to think through what your mission is on site, what the drone should be doing on site before you get to the site. You can also see it in 3D, so you can build, again, a contextual understanding for what the flight plan looks like. And if you wanted to, for instance, in this example, change the flight plan to fly a bit lower, you can change that and see how many pictures it's going to take and how that would impact the 3D view. So essentially, the mission planning is allowing you to think through your flight, think through the data capture, and coming up with the best flight plan for the job at hand. Just want to quickly also mention that you can do other types of flight plans. So essentially, if your mission was to do something like a facade mapping, then you can essentially add a facade plan, and you can configure settings and very much go through the same flow, but for a more vertical inspection mission, more of a facade mission. And once you are happy with your flight plan or mission plan, it's all saved to your Hammer Hub accounts in the cloud, and you can then essentially sync it with the app. So essentially there is a way for you to just send this mission to the app, which is then connected to the drone and then executes this mission on the field. So that's pretty much mission planning in a nutshell. Once you've collected the data, you can also analyze the data. So just to give you an overview for one of the flights that was conducted in one of the Astas in Asda's superstores in Brighton, you can expect to see images like this, which are essentially flown using a drone, and you can see them in a 3D view to get context for your mission, and you can sift through different pictures and annotate those images for any defects that you might find, allowing you to also work with the data that's been captured. But that's pretty much it. I just wanted to talk a little bit about mission, how you could plan a mission in Hammer Missions. I'd now go back to the presentation. So I'm just going to stop sharing. Great, thanks, Joe. So just the last sort of point that I'd like to leave you with is I think the processing and sharing of the data are also really important parts of the workflow, and it's important to sort of understand from the mission planning all the way to the data delivery, what the end goal or the end deliverable is to the customer, and whether it's a 2D map or a 3D model, or if it's annotated images that the customer is looking for, and also the delivery mechanism. So I think gone are the days when you would just deliver the data on a USB drive, I think, or even retransfer, for instance. I think we're moving into the world where project links are being sent to the customers and a report, a PDF report alongside. So thinking through that is really important. And one of the things that I always like to say is that there are lots of tools in the market. There's a lot of things that technology can do, but it's always important to identify your unique workflow and your unique requirements for the client, and then find the tool that best fits that workflow, as opposed to adopting a tool and then building the workflow around it, which is sort of like putting the cart before the horse. So I think it's always about, it's just very much about the customer and the client, and that's really what matters at the end of the day, and delivering a great experience to them. Hopefully this was interesting, and I'm happy to take any questions on mission planning side of things now, if there are any at the moment. Thank you.
Yeah, thank you very much. There'll also be time for questions at the end if anyone has as well, and we'll just say that if you want to direct it to Hammer Missions or myself. Okay. So we'll just go on to the final sort of aspect of our operational sort of mission and planning aspects, is your actual aircraft and care and maintenance that we do on our aircraft. This is just going to be a quick overview of sort of things to check and things that will help out your sort of missions run smoothly and make sure your fleet is all in working order. So we'll start off with the sort of frequent checks that we do. So this is something that I do before flight or every flight. So you want to check first your airframe integrity. So say any sort of cracks or damages to the arms, or any sort of just feel for how it's sort of put together and make sure the landing gear is all on securely, and make sure it won't come off sort of during flight. Another thing is the M300, which is a great tool that we use. I know that's been sort of dubbed recently, sort of having problems with the arm locks. That's something that I take very seriously when I'm flying that drone itself. Make sure them arm locks are on very securely and check them very thoroughly for any cracks or any defects in that themselves, and give the arms a good shake before flight. Make sure it's all secure, and make sure. And next is the propeller integrity. So checking props, checking for any sort of micro cracks or any sort of surface defects, nicks, wears or tears. It's another thing on the M300 that we use. Is huge thing is the propeller integrity, and on any drone. You don't want to be flying with sort of nicked up propellers. On some drones, it could just mean that you're going to lose efficiency. On others, it could be a very serious incident of a propeller exploding mid-flight. Another thing to check is the motor resistance. So is there any sort of grit, or is there any resistance to turning in a motor that could cause ESC or motor failure? Just give it a quick sort of spin just before flight, and check if there's any sort of abnormal bumps or abrasions that you can feel in the motor turning itself. And then cleaning, always clean. I always clean sort of after flight, and sort of make sure your aircraft's clean, because then it'll just work so much more efficiently and better. Another thing is that comes under cleaning is after weather, after sort of using in a rainy sort of day, you'd want to be cleaning off all the water, all the sort of wet residue, even if it is IP rated, or even if it is highly sort of rated for ingress protection. You should always clean off the water afterwards, just to stop any sort of seeping or any sort of that water penetrating while it's in the box and festering over time. You just don't want moisture in there. So next is the occasional check. So this is, say, every month or so that you'd want to be doing when you do sort of a maintenance check over your fleet. So first thing is the screw check. So make sure all your screws are tight, and all the sort of screws that the manufacturer says should be Loctite. Make sure you sort of check that they're good and tight, and got some Loctite on them screws. A deep structural integrity check. So that's really focusing on the main body of the aircraft and checking that there's no cracks or sort of damages to the actual airframe itself, and that might need replacing. Firmware updates, so these could be just sort of life improvement changes for your aircraft, or they could be critical sort of flight critical firmware updates. So we'd advise to always check the change logs. If you're about to go out fly, you find you've got a firmware update, but you're not able to do the update, I'd always check the change logs on the manufacturer's website. They'll always be on there. If it's flight critical, don't fly basically. But if it's just sort of a life improvement change, then you'd be able to just do that operation and then come back and do your firmware updates after. Then calibrations, you do your compass calibrations before flight usually anyway, depending on if you're doing it from a far distance from the last operation. But also the IMU calibrations, they can take a while. You don't want to be doing them on site. You don't want it popping up saying, oh, IMU calibration needed. You can do that every month or so, and that should just sort of abate that. And also the vision sensors, if your drone has it. A lot of DJI drones now, the Mavics, M300s, Phantoms, they'll have their own vision sensors, and that calibration can be a bit of a pain, but it's worth going through every so often, just so you don't get that warning up into a field, because doing it in the field is even worse than doing it sort of just on your desk. And then battery care. So most important is, well, one of the most important things in our aircraft is the batteries, and they're also the most dangerous things. So you want to sort of keep them labeled up, so you can track how many hours you've flown on them and how many cycles you've used them. If they don't have that tracking in themselves, as smart batteries or dumb batteries. If they're paired up, so if it's a dual or even more six battery aircraft, then you'd want to keep them in multiples. That shouldn't say pairs, that should just say multiples. Make sure you are always flying the same pack of batteries or set of batteries with the same set of batteries at all times. You don't want to be mixing, matching between different ages or different cycle counts, because they can also have different efficiencies and it can cause different sort of cell errors and so on. Another thing is self-explanatory. Don't store fully charged. Always sort of make sure they're discharged. If you're storing over anything over sort of 2 or 3 days, it will massively sort of degrade the reliability and efficiency of your lithium polymer batteries if you store them fully charged. And then a battery refresh. So this is sort of every 3 to 6 months. If you've not used your batteries as much as you sort of want, or as much as you sort of can, you might want to be doing a battery refresh if they've just been sitting around for months on end. That would just include sort of charging it up to full, then discharging it up to empty. Then we usually charge it up to full again, and then do a cell check on them. So check the voltage at full, and then leave it for over a day, check the voltage again, and then if there's any cell sort of deficiencies, then it might be a bad battery and you'd have to sort of decommission that. But yeah, that's basically everything on sort of a lower level overview of battery aircraft care and maintenance. And that will conclude our webinar. So I want to just say thank you very much to Varun and Hammer Missions for joining us. If you have any questions now, then please put them in either the chat or the question box. You can also contact me at joe@ether.global, or contact the company at info@ether.global. You can also contact Hammer Missions. I don't know if you want to say anything on that, Varun.
Yeah, no, if there are any questions or any follow-ups, please feel free to get in touch at team@hammermissions.com. We'd be happy to help you out. Yeah.
I think we can hold here. If there's any last questions, we can hold for a minute or so.
Yeah, we'll wait here for a second just to see if any questions come through. And if you don't have any questions and you're going to head off, you'll be directed to a short feedback form at the end, and we'd greatly appreciate if you could fill this out with just any honest feedback you have, and we'll take it on board for our next one. This webinar recording will also be available on our YouTube channel, so if you do want to watch it again or you want to send it to someone, just head over to EFA YouTube, or it'll be on our LinkedIn and you'll be able to see it. But yeah, just want to say thank you so much for joining, and have a great day.
I think there's a message for Varun in there.
Oh yeah, great.
Yeah, sorry, Emily, I think you were going to read out the question. So
yes, so the question's from Richard, and he says, when will the M2EA be compatible with Hammer missions?
Yeah, so it's one of the most frequently asked questions for us at the moment. So yes, we are looking into an integration with the Mavic 2 Enterprise Advanced. It's currently on the roadmap for end of March. The challenge we've got is that we've actually got to do this integration through Android. So we're also working on our Android application alongside. So we're looking to support the new drone with the Android application. So end of March is where we would think about releasing that support.
Okay, so I think that might be the last question. So we'll bring this webinar to a close. Like they said, if you have any other questions, feel free to email either Joe at EFA or info@EFA or the Hammer Missions email, and we'll get back to you as soon as we can. But yeah, we hope you found this webinar interesting and that we've answered any questions you may have. And yeah, have a great day and thank you again for joining.
Thank you for joining, guys. Take care.
Thanks everyone for joining. Yeah, we look forward to hearing from you.